So if I want to take a look at my modeling hints or keywords on page 2, when we talk about a maximum or minimum or a highest or lowest value, we are referring to the vertex of our quadratic. If we want to find our vertex, we either graph it in Desmos and we click on the actual maximum or minimum, or I can take the equation that I'm given and I can use the opposite of b divided by 2a to get the x value, or get the axis of symmetry, and then plug that value back in order to get the rest of my vertex. When I ask about where does it hit the ground, where does it hit the water, where does it start, where does it stop, or how long is it, I'm typically going to be referring to the roots, the zeros, or the x-intercepts of the quadratic. So again, where do I cross that x-axis? So if we look at this very first example together, it shows the height in feet of a small rocket t seconds after it's launched. So my y-axis, if I look, says height, and my x-axis is time in seconds. And so I've got an equation that models it. H of t is equal to negative 16t squared plus 128. And it asks me, hey, how long is my rocket in the air? Now, t is time, and if I look at where my rocket was launched at time 0, it looks like it landed at about 8 seconds. So my rocket had to have been in the air for 8 seconds. Now, the greatest height that the rocket reached, again, that's going to be where my maximum was. So I'm going to take a look at my maximum. And it looks like I'm somewhere in between 250 and 260. So let's just call that an even 255. So we're going to say it reached a maximum height of 255 feet. And then it asks me, hey, when does it reach that maximum height? At what time? So I'm going to try and find the x value of that vertex. And if I draw a straight line, it looks like I'm right at the 4-second mark. So it reached that maximum height after 4 seconds. Notice that that maximum height is halfway in between the 8 seconds of total travel time. So that maximum came right in the middle. When it asks me, hey, where is your graph at, or how high is the rocket after 1 second, I'm going to go look at t is 1. And if I go straight up at t is 1, I've got a height of 110. If I take a look at 6 seconds, I go to my graph and I can see that it looks like I have a maximum height, well, not a maximum height, but a height of 190 feet at 6 seconds. And then if I want to know the interval where the rocket's height is increasing, that means that I care about how long is it going up. So if all I care about is how long is it going up, from the moment it launches until the 4-second mark, my rocket is increasing. And then all of a sudden it starts to go down and it's losing height. So my rocket was increasing from the interval of 0 to 4. And again, that notation may look fancy, but that's just interval notation. Again, my height was increasing from 0 to 4 seconds. T was the variable that my question told me I was using for time. So since t was the variable that I was using for time, that's why I used t as my variable in that format. The very last thing I'm asked is to use my equation to find the exact value of the height of the rocket at 2 seconds. And so I'm going to take my equation, I'm going to plug it into Desmos, and I'm going to see what I get. So I've got negative 16t squared plus 128t. Take negative 16, I'm going to make it an x squared plus 128x, and I've got a pretty big quadratic. You can see that my window zoom might not be the best, but I'm going to hit the settings button, tap the table button, and when I plug in a 2, it looks like I get an output of 192. So again, I'm just looking at the table that I get by clicking the settings button, pressing on the table, and then when I have an input of 2, I get an output of 192. So H equals 192 feet. So again, I was given a graph from the very beginning to use. I used the graph to answer almost every single question, but then I wound up graphing it into Desmos to get a couple of the extra answers that I needed. And you are more than welcome to do that too.